Alright, let's take a look at 16.1. So it's asking us to calculate the annual depreciation value by using straight line depreciation. And that is our equation right there. It's 1 over n times p minus s, and those are some givens over here. So p is our initial investment, or our initial cost, which is $20,000. It's going to be depreciating over a period of 8 years, and our salvage value is going to be $2,000. So when we plug that into the equation, we get 1 over n is 1 over 8, and our p minus s value is 20,000 minus 2,000, and that gives us $2,250 of annual depreciation. And when we put it into a graph, the y-axis being in thousands, we see that every year, starting at $20,000, it goes down by $2,250 every year until it hits the 2 value, which is kind of small. But it goes down after 8 years and hits that salvage value and just continues on from there. And that's the answer to 16.1. So let's move down to 16.2. Okay, and this problem is asking us to use the total sum of years digits equation and to compare our values. So I have that equation right over here. So SOYD, sum of year digits, is n over 2 times n plus 1. So when I plug that in with what we were given from the first problem, that's an 8 over 2, which is 4 times 8 plus 1. 4 times 9 is 36. And once we have that number, we can look at this equation right here, n minus t plus 1 over n over 2 times n plus 1, all of that times p minus s. And we have to do that for each year. So let's take a look at what that looks like. So when we actually do the actual computation, d sub 1, it's going to be 8, which is our n value, and then minus t, and we're starting out at 1, so it's going to be minus 1 plus 1, and then over that value that we just calculated, the total sum of years digit, 36. So we take that and we multiply that by $18,000, and that's 4,000. And then for the second year, d sub 2, you're going to do the same thing, but your t is now going to be 2 because it's the second year, and you're going to calculate that out. It's 3,500. And then for year 3, you're going to put in a 3. It's 3,000. Year 4, it's 2,500. And you can see the trend. Year 5 is 2,000. Year 6, 1,500. Year 7, 1,000. And it finally ends up at 500. And you can notice when you sum them all up, it equals 18,000, which is your book value, which is your p minus s value, which makes sense. And according to the book, this can be helpful because if you notice your first couple values up there, 4,000, 3,500, 3,000, the first 3 years, all those values are going to be over what you got from straight line depreciation. So it was saying that you could take that money and reinvest it and compound it, and sometimes that could be useful. So I put that into a table over here. For your book value, every year you start with 20,000 and it goes down by 4,000. Therefore, you have 16,000 next year, and you go down by 3,500, and so on. And that is how you use the total sum of years digits equation to calculate out depreciation. And then finally, for 16.3, it's asking you to, again, calculate depreciation, but by doing declining balance, or double declining balance depreciation. So let me move this book out of the way. So the double declining balance depreciation, the equation is still 2 over n times p minus s, which is your book value. P minus s is always the book value. But there's a little bit of a twist in how you use this, because you're adapting your book value the whole time. So when you calculate it out, it's going to be 1/4 the book value because it was a period of 8 years. So that means that let's see here. For year one, your book value is $20,000. So if you take 1/4 of $20,000, you get 5,000. And then when you subtract $5,000 off of $20,000, you get 15,000. And then you plug that new book value back into the equation, so it would be 1/4 times 15,000, and that would give you 3,750. And then you subtract that off, and you have a new book value, and you take 0.25 of that value to get that number, and you do that all the way going down. And when you see at the end, because of rounding errors, it might have changed a little bit, but you're basically at $2,000, which is your salvage value. At the end, I got $2,002.27. So that's just a third way to calculate the same thing. But the second part of the problem was telling you that you can also compare a straight line depreciation, and they give you an equation. It's 1 over L, which is your lifetime remaining, times the book value minus S. So I put that into a table over here. So for your life remaining in your first year, since there's 8 years, you're going to have 8 years remaining. So by using the equation, you have 1 over 8 years remaining, and your book value is 20,000 minus your salvage value, which is $2,000, which gives you 2250, which is the annual depreciation that we got from our first one, from 16.1, which is pretty cool. And then going on to 7 years remaining, you'd put 1 over 7, because 1 over L, and you'd use the new book value that you'd get, which is $15,000, which you derive from this table right here. So this is your BV sub T, and there's 15,000 for year 2, which means that you use 15,000 in the equation to get 1857.14, and then you do the same thing, 1 over 6 times whatever value you have over here, 11,250 minus 2,000, and you'd get a value, and you'd keep doing that until you get all the way down, and that is your straight line depreciation value that you can compare against your DDB value that you calculated. So that's called with switch to SL. Basically, that's what that's asking for. And that's pretty much the first 3 problems. All right, thanks.